Hello everyone and welcome to CVO, Curricular Vitae Optimization by recommending keywords to undergraduate students. I'm Cibele from PUC Minas and the first author of this paper. This is our agenda. We're going to talk about the context and motivation, the goals and contributions, the related works, methodology, experimental results, and conclusion. So, in context, the undergraduate student's career begins with an internship where they can validate the skills learned at the university. In this context, there is increasing competition for internship vacancies in which students are evaluated first by their curriculum vitae. In order to optimize hiring recruitment systems, are used to rank candidates similar to CVO, Search Engine Optimization, but using the curriculum we have the CVO, Curriculum Vitae Optimization. However, most resume recruiting systems focus on candidate selection for companies. There is no feedback for internship candidates who do not have all the skills and do not know what skills to acquire due to the lack of experience. As a result, they don't know how to optimize their resume. And as mentioned by Wang, there are some problems that students face. University and the current job market, the courses and skills learned by students may not meet the needs of companies, and there is a lot of false and confusing information in online recruitment. So, how to analyze a resume by characteristics of similar profiles? How to classify a resume? How to optimize a resume through skills and feedback? We propose a curriculum vitae optimization system that allows the characterization of groups of university students who are candidates for internship vacancies through the extraction of keywords from the curriculum. It's possible to improve candidates' profiles by receiving recommendation of competence and feedback to achieve effective placement in an internship. The main contributions are a methodology using machine learning based cluster and classification techniques with similarity functions are used to enable the undergraduate students to understand their CVs, the use of NLP techniques, natural language processing focused on undergraduate students, not on the recruitment process, and the recommending CVs keywords made it possible to know the level of the internship candidate's resume about its competitors and enable the undergraduate students to improve their CV. In the related work, we divided the papers in three groups. The first one is selection of candidate skills. There is the characteristics were relevant in the selection of candidates. Then we have the clustering of CVs, which is how the clustering technique contributes in the work to relate and classify candidates, and in the end the recommendation system, that is the use of skills recommendation and feedback based on profile clustering. And how my work is among the others. So in the selection of candidate skills, we worked with a diverse base, and we used pre-processing NLP and TF-IDF using the keywords and a private base. In curriculum vitae clustering, we used a combination of clustering and classification techniques and the evaluation of more than one technique with the profile similarity. In the recommendation system, we use the content-based recommendation and skills recommendation profile feedback. It's important to understand that this work focuses on internship profiles, the skill set as a whole, focus on the candidate, not the vacancies. And this is the methodology steps for the proposed approach. So this is the methodology. The first step is the data processing, which we use all the steps of an NLP process, and in the end the TF-IDF calculation, followed by the clustering, which we use eyeball and silhouette method in k-means to find the optimal number of clustering, and with a cluster analysis, followed by the classification, which we divided in training and test the data frame, and evaluate 5 techniques of classification, followed by the experimental results with the Cosine similarity and analysis of results, and finally the recommendation system with keywords and feedback. So in the data processing step, we have a private database with user identifiers, courses, cities, and keywords, previously extracted from university students' curriculum, totaling 163,885 records available in JSON format. The records removed were course names, behavior skills such as calm and patient, because here we want to focus on hard skills, study shift, university, and city. And in the NLP process, we have the unification of these words per user, resulting in 7,202 records. In the pre-processing step, vectorization was performed, then the removal of stop words from a Portuguese dictionary. Finally, the stemming step, keeping the lexicographical part of the terms. For example, in engineer in Portuguese, we have 3 denominations, so we put just this lexicographical part engine. After this pre-processing, we have a calculation of the TF-IDF matrix. Here we consider the big grams terms. It means 2 words. So this TF-IDF is the inverse frequency of the term in the document, and after the calculation of this frequency, we can calculate our eyeball curve and silhouette method in order to find the optimal number of clusters. That was 9. And we executed k-means algorithm and made a cluster analysis, creating a cluster dictionary to understand better which clusters was formed on this clusterization. So here we have the 9 cluster that was obtained from this clusterization. We have the generic administration clustering in dark blue, and we have accounting science, psychology, civil law, web development, human resources, generic customer service, advertising, journalism, civil engineering, production. You can see here in dark blue that the generic administration cluster is the largest cluster. This is due to the low variability of words in the profile, or words that are not very relevant and present in all the clusters. For example, Excel and PowerPoint and Word is words, keywords presenting the most part of the curriculums. So after the clusterization, we plot this word cloud figure with as the words are closer to the centroid, they get bigger. For example, we have here web development. And after this clusterization, we divided the data in 80% training and 20% testing to make the classification. We used the train test split module from Python's sklearn library, and we evaluate 5 algorithms to comparison: random forest, SVM, decision tree, KNN, and naive Bayes. As a result, the algorithm with best classification performance in the score and accuracy items was the SVM with .92 with a score and accuracy of 94%. This accuracy metric was obtained through the cross-validation method, which consists of evaluating the generalization of the model. After this classification, we made our experimental results. And after classifying the CVs, the Cosine similarity index between the first 50 words of the cluster and the words of each resume was calculated. It was made through the similarity of 2 vectors that evaluate the cosine value of the angle between them. This is the cosine similarity calculation. So after this, understand that we used this calculation, and after calculate the cosine similarity of the profiles, the cluster similarity was calculated with the words of internship vacancies found on job vacancy sites on web, using the intersection of vocabulary. And a quality classification of the profile was created where labels were assigned to facilitate the understanding of similarity calculation. If the curriculum has more than 50% similarity to the cluster, it's considered skilled. It's a skilled profile. If the curriculum has between 25% and 50% similarity with the cluster, it's considered average. And if the curriculum has less than 25% similarity, it is considered inexperienced. So this is the result of the profile quality categorization by cluster. As we can see, we have some clusters that have skilled profiles as psychology, accounting, sciences, and in generic administration, the most part of the profiles are inexperienced, but we already have here some skilled profiles. And after this categorization of the profiles, we go to the recommendation system, and the recommendation was made using 3, 5, and 10 keywords. The similarity of the profile with the cluster after the recommendation was calculated, and we provided the position in the cluster that the candidate ranked according to the quality category of profile. And the resumes with this recommendation was filtered according to medium and inexperienced, because the skilled are already skilled. So we have on this flow of feedback results to candidate the words in student curriculum, which in our recommendation system provides a profile cluster, a distance from profile to cluster, a profile quality, a recommended words, a distance from profile to cluster after recommendation, a ranking position in the cluster, and a feedback message. This is an example of one of the 3 of the records with this recommendation. And here we have the first one, which is an experienced profile. The second one is also an inexperienced profile, but the first one is among the 10 of the top 10, and the last one is a medium, which is also in the top 10. So let's take a zoom on this first one. We have a profile with words about accounting and nursing, and this was classified with accounting sciences cluster. It's considered inexperienced, but is the first one of the inexperienced. We can see here a dot 24% of Cosine similarity, and these words on this profile. And the message feedback is: you are among the top 10 of inexperienced profile on your cluster. Check our skills recommendation and improve your profile. So after the skills recommendation, this profile with dot 24 goes to dot 43. It's an improvement on this curriculum. So after improve all the curriculums, we take the similarity increase, suggesting 3 words. We can see here improve of this of all the clusters, the number of similarity. In psychology, for example, we have 50, then 24, then 20, then 33. And we have the similarity increase suggesting 5 words and 10 words. And after this similarity, we calculated the mean cosine before recommendation and the mean cosine after recommendation. So we have here an increase of, this is through all the profiles, and we have here increase with 3, 5, and 10, and we have increase of 80%, and 31%, and 50%. It can be said that the results were positive, with a minimum increase of 80% using only 3 terms. This means that the algorithm improved the student's curriculum. So as a conclusion, we have analysis of relevant groups of university curriculum profiles. We have also the evaluation of different types of classifiers. We understand the distance of undergraduate students' profile on each cluster, and the experimental results show that the recommendation improved with the similarity of students' curriculum, competitiveness with a specific field, from 80% with a 3 keywords recommendation to up to 50% with 10 words. So, as future works, it is intended to expand the data set to find new profiles of undergraduate curriculum, and deep learning techniques to find more keywords and skills relevant to students' profile, and a tool for candidates to apply the recommendation in practice, optimizing the resumes and being more suitable for vacancies in the professional market. Thank you.